Hello, everyone. I am Leo Atencio. I'm with Prometheus Materials, and we are based in Colorado, and I am here to talk to you about our bio-based cement and bio-based concrete. So appreciate the opportunity. We just presented to the Rocky Mountain chapter in Colorado in February, I guess it was. So pretty much the same type of presentation, but if you have questions as we go along, please feel free to ask. So a little bit about us. We are based in Colorado. This is the leadership team. Loren, who's here, he's the CEO. I'm the director of product management. We have Dr. Stephen Bell, who's our director of biotechnology. He's in charge of algae cultivation. Vaughn Bigelow is our director of manufacturing, looking over our manufactured goods. And then Dr. John Hoddle is our Director of Research and Development. So a lot of the analysis for chemical and physical stuff falls under him. And then within that, we've got a team of material scientists as well, and a production crew. So a couple things for us. My experience is in the cement and ready-mix industry. It's been that way since the mid-90s. I came from very large international cement companies, worked on their ready-mix products, always in sustainability. So when this opportunity came up, I was super engaged and excited to do that. The leadership team as well. This is part of our DNA, and so we are passionate about helping do our part in contributing to low-embodied carbon solutions. Some of these stats are industry-wide, so I won't spend too much time on them. Obviously, the concrete is the second most used material. 40% of the CO2 is responsible in the built environment. Some of the statistics we see on the marketing side is adding another 120 billion square feet by 2050. And to put that into relation, it's basically building a New York City every month for the next 20 years. That's the building demand. And so it is, and it's a responsibility that we see as contributing, right? None of us can do it on our own, and we're looking at ways to contribute and collaborate with cement and ready mix, and even, you know, on the aggregate side, helping them as well with our technology. We found the PCA did a roadmap, which we think is great, and it's a carbon neutrality. So if you get a chance to read this, it's a pretty in-depth roadmap for them. We found that we contribute along their value chain at the top. So whether it's in the clinker side, cement, concrete, construction, and obviously the carbonation piece, we just found synergies along those lines, and we're excited to see the path that the cement industry is taking. A couple things that they line out in the roadmap, obviously, is looking at the current cements, using less than 5% of the materials, and they have increasing ratios, 2030, 2040 and 2050, which aligns with a lot of the architecture 2030 and 2050 targets. And they're looking at as well the tomorrow cements taking up less and less clinker. So for us, it was a perfect synergy for us to look at where we can impact right out of the gate. And again, I just sometimes it's hard to read in those, so I just kind of blew it up. For us was, on the previous slide, was the ability of them to really take into consideration SCMs. And so that's where we kind of looked at some of the things as a new technology, new innovation, is looking at changing a lot of those standards from prescription to performance. And that a lot of that work is being done by NRMCA. It's taken a while, but we do see greater strides and more motivation right now to do it because of all the new technologies. I mean, not us alone, but there's a lot of innovative solutions coming out, and now we're starting to see them move quicker. This has always been a policy I can remember going back to 2000, but over the last couple of years, it's moving a little bit more quickly. The other thing that's helping too, obviously, is you've got legislation, and we see this around many states. It's coming up on another slide that they're looking for low-embodied solutions within the materials industry. So the EPA and the GSA each have mandates addressing embodied carbon, with whether you want to get into the GSA network or if you want to start working on a lot of the government buildings. For us in Colorado, we have what they call it the Buy Clean Colorado Act. We were in New York a couple weeks ago, and we really targeted that market because not only the city of New York, but the state of New York has looked at different low embodied carbon solutions as it comes to new construction. These states right now, so Oregon, California, Colorado, Texas, New York, Massachusetts, New Jersey, all have the same type of rigorous specifications that they're looking at, which really accounts for about 32% of the population just in those states right now. And we see those specifications growing, and both on the engineering side and the architecture side. So we're excited to see ASTM, ACI looking at, and even the building code, ICC, looking at how do we address those and really getting pulled in that direction. We did 2 market analysis, a green building cement segment and a green building concrete segment, and that's what they show as the growth. So it's not going away, and those are global. Right now we're really concentrating on the US, but we definitely know that international is going to be an opportunity for us to keep moving forward. So kind of getting into who we are looking at microalgae. So basically this is where we fit in. We're taking what nature does when creating seashells and reefs and accelerating it to make it effective and efficient solution. So microalgae has been around for a while. It really is 2 ways of cultivating: photobioreactors, which is really a bag and cage system, or outdoor raceway ponds, and we have a couple of examples of those. Right now, we're using indoor photobioreactors, but we are targeting going outdoor raceway ponds. Some of the applications that microalgae's been in is animal feed. Most people are really familiar with it as a biofuel, but it's in cosmetics, so it's nothing new. All we've done is taken some of that technology and looked at a way to replace cement. So what we do right now is we take an indoor photobioreactor, or you can use an outdoor raceway pond. You're getting the nitrogen, phosphorus, potassium, and the CO2 is coming from an air or industrial resource. So right now, this is inside of our facility. It's a small cage, bag and cage. This is an early picture. Now we have, I think there's 3 or 4 of those photobioreactors. But this is what an outdoor raceway pond scale would go to. So this is our strategy for scale up. You're basically taking, the algae cell precipitates calcium carbonate under certain conditions. You get the CaE2 source from calcium salt or seawater. And then you get the bicarbonate sources ultimately from the air or some type of industrial sources. So we get it, we put it in an evaporation pond, so we don't use any type of heating. It ends up a slurry, separates, we evaporate dry it, so we don't have any type of heat. Then what happens is we take that biomineralization, we add a few other proprietary constituents to it, so still but none of which are OPC or fly ash or even apozolin right now, and that becomes our biocement. We take the biocement, and right now we've put it into a conventional block machine, and we started doing the blocks. We have a booth downstairs, so the bioblock is basically created that way. We took the bioblock for us as the first step into introducing this technology, mainly because it allowed us to look at the total cementitious piece using just our technology. We have gone through a lot of ASTM certification. So we took the ASTM C90 boilerplate template. The only thing that we're going to do with ASTM is change the verbiage into a new standard. All the performance stays the same. We'll just look at using microalgae geopolymer as the scope language. We have completed these tests for sound absorption and thermal conductivity, which are unique to this material. It really absorbs 12 times more sound than a conventional CMU, and it does have an R value almost twice as much as a conventional block. It's not anything that you're going to just be able to put up without some type of insulation, but it definitely has an R value. And then because we don't have Portland cement, they've asked us to look at fire. So we have done what the combustion testing and passed that. We have completed E84, which is the Steiner tunnel, and it's a flame and smoke index. And right now, so everything on the left is things that have been completed by a third-party laboratory. And then on the right, the stuff in progress. When we did the prisms for the block, they were full cell. We used the International Masonry Institute. They'd asked us to do them hollow so that they could really test the bond strength between the grout and mortar and the block. So those are being retested as hollow forms. That's what that means. Obviously the freeze thaw is critical for us, especially in Colorado, and really going to throughout the U.S. You get into the East Coast, so we are definitely identified that. And the final one is 119. That's the Cadillac of all the fire tests. So they will build a wall, put a load to it. They'll put flame on one side. Once that's done, we will be able to kind of put a stamp on the block and move on from the block. So these are kind of a high-level view of what we've received as far as performance standards. Again, these are all third-party tested, whether it's there in Colorado or we've had to send some of these out to some other labs. So we're always looking to partner with other labs throughout the U.S. So we definitely welcome that partnership. And it's just an 8x8x16 block. We started out with a 6x8 because that was the pilot mold we had. But we definitely understand that that's the standard block. We just, right before the end of the year, got the smoke and flame index, so we were extremely excited about the Class A rating on those. Where we've been, we always get a question like, where is this being used? Right now, we've been doing it on pilot and demo scale. We've been fortunate to work with the IMI. SOM is a architect, Skidmore, Owens & Merrill. They are known for the Burj Khalifa as well as One World Trade Center. So they've been a firm advocate for us. We sent blocks down to IMI and they did a lot of constructability tests for us. SOM never does anything easy, so they did a serpentine wall that they designed. They used conventional type S grout. And then the IMI team, they brought in a lot of their masons and looked at fasteners and tapcons. And we got a lot of good feedback in regard to how our block works, some of which they didn't need to pilot drill, which to us, we didn't know what that meant, but to the masons, they're like, oh my gosh, you just cut our time in half. So that was a big one. And then with this particular mix design, they were able to seal it with just a wood sealer instead of a conventional, because we don't have the same reaction that an OPC block would have. So just some different unique qualities. Then in September of last year, SOM invited us to go to what's called the Chicago Architectural Biennial. It's the Parade of Homes for Architects. We built a wall down in Fulton Market. This was the one that was exposed. Everything at IMI was indoors. So we wanted to make sure. So we had to do some flame tests, some real quick flame tests, because the city was like, we want to make sure that nobody does that. So that really expedited some of our flame, and we were happy to report that we didn't have to worry about any issues. Again, they did a circle wall, and it actually was supposed to stay up till January, but I think it came down at the end of March. And they wanted to leave it up because they were getting really good traffic and people wanted to come see it. So it was great. So for us on the development side, so what's left, we presented to ASTM back in December, and we started looking at our biomaterial as an SCM. So we're doing a lot of those chemical and physical analysis now. So that'll probably take most of Q2 and Q3 to get those results back. But some of the preliminary stuff, these are all in-house tests that we've done using Type 1L. In Colorado, all we have is Type 1L. There's very little Type 1-2 cement being used. So you'll see the GWPs per kilogram, and then the graph on the right is the percent replacement. So those are our breaks at seven-day breaks, with the control being 100% of Type 1L, 14-day breaks, 28, and what we really get into is when you get into a true GWP. Now this is just the cementitious part. This doesn't include the aggregate and those, but you can see how with our biomaterial, we're able to lower the GWP of the cementitious content, and a lot of that is the biomaterial itself when it comes out of the lab is negative already. So it offsets a lot of those properties within. One of the things we haven't done yet, and we're looking to do this year, is introducing any type of admixture. So this has just been water. We haven't done a high range or a mid-range water reducer. We expect to see even better performance as we start to introduce some of those innovations in admixtures. And some of the things we've done, we just did an in-house real quick mock-up wall because we wanted to look at its contribution or the impacts on rebar. So we just did a real basic 6-inch thick wall, 1.5 feet high, 4 feet long, 40% blend. And then on this wall, we changed the mix design a little bit. So those are our 7-day and 28-day break on the wall that we have right now. But we're excited to see where it goes. We still have to get to the physical and chemical analysis completion, and then we will go back to ASTM in June and present the findings and try to keep the ball moving forward. So for us, the next steps, obviously the analysis that we talked about, we always look at third-party testing validation. Not every lab in Colorado can do the stuff that we need. And the standards that we're looking at, ASTM, ACI, and ICC. And then for us, the scalability, we always get questions on scalability. That is definitely in our wheelhouse for 2024, is to get where we can start to manufacture the bio at large scale. And then we are looking for collaborations with third party, whether that's a cement supplier, ready mix supplier, or brick supplier. That's where we really want to try to get into what we call friendly job sites. And with that, that's all I've got. So I appreciate the time. I'm more than happy to answer any questions.